طيب بسم الله الرحمن الرحيم. Last time we started to talk about IP version 6 special addresses, and we talked about 5 different ranges of IP version 6 addresses. These are on the right hand side here. So we have global unicast, which is routable through the internet for unicast address, link local, which gets assigned by default for all nodes, and it's used only within a LAN. Loopback, of course, it's used for troubleshooting, and then unspecified, which is used as a source address only in case the node wants to be anonymous or it doesn't have any assigned IP address version 6, or the unique local, which can be used within an enterprise to cover multiple LANs. As we said, this is the closest to the private IP addresses, except that these are not to be translated. These are to be blocked by the default gateway of the enterprise. So very quickly, we need to categorize these addresses within these ranges. So the ranges are here, okay? So we notice here, of course, we have /10, where here we have FC/7, and of course, as you can imagine and logically, these two ranges are separate. These are not overlapping, and they should never be overlapping, of course. What is the category of the first IP address here? Is it no, unspecified is actually all zeros /128, so it's not unspecified. No, neither loopback. Loopback is actually all zeros except the last hexbit. In fact, this is global is actually 2. So it's actually none of the above. It's not applicable. Well, in fact, there are, of course, some IP address version 6 which are not in any of these categories, and that's one of them. So 1::1 is not here, is not any of these ranges. So it's not applicable. These types of addresses, by the way, can be used as unicast addresses. They can be used because, as we said before, this global unicast is actually a recommended range. It's not a must, which means that IP addresses that are outside of this range and outside of all these 5 ranges, they might also be used as routable addresses. But the standards actually defines this global unicast only as a recommended range. Okay. Type FEA::1 in which range? So this is FE8. I apologize that maybe so this is FE8/10, and this IP address is FEA0. So does it actually lie in this range? Yes, يا جماعة في إيه؟ Yes. So because this is FE8 and this is /10. So F is 1111, E is 1110, and 8 is 01000, right? And this is /10. /10, which means that until here. Okay. So when we say FEA, A is in fact A. It's 0, 1 and 0, 1, 0, right? So of course the first 10 bits they match. So this is in fact link local. Okay. This is of course unspecified. It's very straightforward. FEBB. Okay. Same thing. This is FEA/B. B is like A+1, which means that this bit is 1. So this is also link local. 22::23. In what range? None. Bravo, Alek. Yeah, none of the above, or not applicable. Why? Because remember, 22 here is in fact 0022, and I omitted the leading zeros, right? So the global unicast here is in fact 2000. So clearly there is no match. which means this address is not in the global unicast. And of course, clearly it's not in any of the other ranges, so it's not applicable. Type FC11, in which range does it lie? This range? Yeah. So unique look, yes, unique look. And FD, of course, is also a unique look. Okay. All right. Yeah, go ahead. Do you have a question? Uh, no, eight. Well, yes. Well, eight is sorry. Eight is 1000, right? So eight is in fact 1000, right? Right. So I was, yeah. So maybe here there is a small mistake here. So eight is actually 1000, right? And A is 8 plus 2, so it's 1010, right? Yeah, so the first two bits they match, right? Because it's slash 10. So it's still there is match, so it's still in that range. So this is actually correct, except that maybe the conversion to hexadecimal was not. So now we need to discuss a very important topic. In fact, today's lecture is a bit يعني tricky, and you will appreciate the fact that if you watch the offline videos before this lecture, you will understand things much, much better. So we'll talk about IPv6 address configuration. Okay. So IP version 4 address configuration is actually one method. So we have talked about a way to assign IP address version 4 automatically to nodes using what protocol, ya shabab? Anyone can answer. What protocol is used to assign automatic IP addresses to nodes in IP version 4? DHCP, right. So DHCP is an application level protocol which is used by IP version 4 to assign automatic IP addresses to nodes. Okay, so when a node first starts, it should try to reach to a DHCP server, or it looks at the an address in the cache or in the TCP IP configuration. If it finds the address, then it's fine. If not, then it has to go through DHCP. So from DHCP, it gets. So we need set of things, not just the IP address. So we need the IP address, okay, which is the full 32 bits in the case of IP version 4. We also need the gateway address, because this is very important. This is our postman to the outside world. And we need what we call DNS. So DNS. The DNS is a, well, it's optional, but it's also important for completeness in order to be able to communicate with the internet. So if I say google.com, I need the IP address of the Google server. So in order to communicate with it, when I say, yahoo.com, I need the IP address and so on. So if your browser is smart enough, it will cache these IP addresses. In which case you can, access the web servers that you frequently access every day, even if you don't have access to DNS. But if you try to access a server for the first time, or a weird server that you did not access before, then you have to connect to DNS to get its IP address. Okay. So we need all these information for IP address configuration. So when I connect to DHCP server, Okay, for IP version 4, I can get all these 3 pieces of information. Of course, in addition to the IP address, we get also the net mask, right, or the prefix. So IP version 6 is a lot more complicated, in fact. So IP version 6 divides the address into what? Into prefix and interface ID. Okay, so this is IP address version 6. IP address version 6 is 128 bits. Typically, the prefix is 64 bits, which leaves 64 bits for the interface ID. Okay, so we need the prefix, we need the interface ID, we need the gateway address for IP version 6, and we need DNS version 6, right? We need the DNS server that uses IP version 6. Okay, so all these information we need so that we can have, fully operational IP configuration. Okay, so for IP version 4, as we said, the only method that's used is just to connect to DHCP to get all this information. In IP version 6, we have 3 different methods. 3 different methods. Anyone knows what these are to get the bonus? Methods. 3 different IP version 6 configuration methods. حسام تفضل. The Slack, تمام. The stateless auto address configuration. Stateless auto address configuration. لو شرحت لي stateless auto address configuration, how it works, حسام, you get the bonus. Since you remember only one. Okay. طيب حسام ماشي ندي لك حسام. Okay. So stateless auto address configuration works as follows. So you have, of course, the LAN has a router, right? So when the nodes start, okay, maybe they have some delay to connect to DHCP, okay? So one method that exists in IP version 6 that does not exist in IP version 4 is based on the technique of Slack or stateless auto address configuration. And what that means is the default gateway will automatically send something called route advertisement. Route advertisement. This route advertisement sends information on the LAN that is common to all the nodes. Okay, so these information include: one is the prefix. Prefix, of course, is which corresponds to the network address, right? So this network address is common. So only the prefix, not the interface ID part. Okay, only the prefix. And of course, it sends the gateway address. Okay, so it sends the prefix and it sends the gateway address. Okay, so in that case, we have 2 pieces of information for each node missing. These 2 pieces of information include each node will need the interface ID and the DNS. Okay. Remember, when I talk about Slack is a network layer technique. Okay, because we're dealing with routers here, and routers will send route advertisement to all the nodes. So in Slack, we have 2 pieces of information missing: the interface ID of each node and the DNS. So each node is responsible for assigning to itself an interface ID. Okay, so each node will take this information and then it will assign to itself an interface ID. Okay, so it assigns to itself an interface ID through a method which is called EUI 64. Okay, this EUI 64 It works as follows. We need to assign to each node an interface ID that guarantees uniqueness. Okay. So what do we have inside each node? There is unique, globally, even through the entire, internet. Okay. What is the address that's guaranteed to be unique for every single node on Earth? No. واضح ان في تخمين. No. This is the MAC address. The MAC address is the physical address which is represented by two parts. Remember, huh? The MAC address is 48 bits, and again it's composed of two parts. The first part is what we call organizational unit identifier, which is 24 bits, and the NEC ID, or the network card ID, okay, which is unique for that network interface card. Okay, so interestingly speaking, a network layer protocol will use the MAC address to assign an interface ID as part of the IP version 6 address. Okay, that might be a shock to many people now. Again, so a node will use its own MAC address to assign to itself an interface ID, which is part of the IP version 6 address. Okay? Type. So as we said, typically, the interface ID part of the address is in fact 64 bits. Okay? But the MAC address is 48 bits. So what do? We need to map the 48 bits to 64 bits. Okay? So what each node does is that they use the procedure called AUI 64 procedure. And that procedure is composed of two steps. The first step is very easy, and it's based on the fact that, okay, so I will take, since I have 48 bits and I need to map them to 64 bits, I will take the first 24 bits and I will put them here as they are. Okay, so this is the 24 bits. And I will take these 24 bits and put them at the beginning. Okay, so these 24 bits will be here. Okay, so I will be left with 16 bits in the middle. فقال خلاص, put these 16 bits as fixed. So we'll put them as F, 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 E. Okay, F, 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 E. And these will be fixed. So this is step number one. Step number two, we'll take the seventh bit here. Okay, seventh bit in the physical address. Okay, here, somewhere here, which is in the second hexadecimal digit. It's the third bit of the second hexadecimal digit. And then toggle seventh bit. Okay, toggle means what? If it's 0, make it 1. If it's 1, make it 0. That's it. Okay, so that's the EUI 64. So EUI 64 maps the physical address, that the 48 bits of the physical address, to 64 bits of the interface ID in the IP version 6 address. So we'll do that procedure in a minute now. So this is the first method, which is called Slack. Slack, in fact, it produces all the information except DNS. So DNS will be missing. So that's why the second method, it uses the Slack together with DHCP version 6. Okay. So if I have a delay to communicate to DHCP version 6 server, okay, I can get myself going using Slack method. And hopefully all the IP addresses of the frequent websites that I use are already stored locally in the cache. There is a chance this is not the case, in which case I will have to connect to DHCP to get, in addition to the prefix, okay, and interface ID using AOI 64, and then the gateway address. In addition to that, I will get the DNS from the DHCP server. Okay, so in addition to the Slack, I will get the DNS server, and in fact, DNS is not just one address, by the way. It's like 2 or 3 addresses. I will get them from the DHCP server. So if when the node starts, it can get access directly to DHCP version 6 server, then and only then it doesn't need to use Slack or the AOI 64, in which case it will get a full IP address version 6, not just by it will not use AOI 64 at all. It will get a fully routable address in the range of, as we said, 2000:/3. It will get a full IP address version 6, in addition to the gateway, in addition to the DNS. واضح كده؟ Okay, that's if and only if I can get access to DHCP version 6 server before I get the route advertisement from the router. If I get route advertisement from the router, then I can use the Slack method to assign a local address which is based on the MAC address of the node. Okay, so we'll all right. So yeah, to do some exercise to make this concept clearer. So here in this exercise, a node has a physical address that looks like this. This is the physical address of the node, FC99.4775 and so on. Okay, so that's the physical address of the node. The node received this assigned prefix from the router through route advertisement. Okay, so how can the node assign to itself a full IP address version 6 based on the AOI 64 method? So as we said before, the method is straightforward. So first, we need to take that physical address, and we'll divide it into 2 parts: 24 bits on the right-hand side and 24 bits on the left-hand side. Okay, so this is the first thing. So we will take the FC99, okay, and then this is 1 hexbit in the IP version 6. So we'll put like this, and then 47. So this will give us the 24 bits on the left-hand side. You see? And we have on the right-hand side, we have 75, and then colon, and then C3E0. This is the 24 bits on the right-hand side, okay? But in fact, we need to make this 64, in which case we need to embed in the middle 24 bits. So these 24 bits are fixed, which is F, and then colon, FE. Okay? So that's it. So this is the 64 interface ID, which will get generated automatically by the AOI. Of course, this prefix address is /64, which means that the interface ID is all zeros because this is a prefix address, right? So we need to put this 64 bits in the IP version 6 address. But remember, this is the first step in the AOI 64 procedure. The second step is to look at the 7th bit here in this digit, the 7th bit in this digit, and toggle it. So C, remember C is 12. C is 12. So C is in fact 1010, right? So this C is صح is 12, right? Yeah, it's 8 plus 1. Okay, 1 1, sorry. Yes, 8 plus 4, sorry. Yes, 8 plus 4. Yes, you're right. 1100. Yes, exactly. So 1100. Okay. So we'll take the seventh bit, and we toggle it. The seventh bit is 0, so we toggle it to 1. So the C becomes E, right? So the full address becomes as follows. So then the full address becomes as follows. So we have FE 80 colon colon, and this is a 64 bits that represent the prefix. Okay, the other 64 bits will be as follows. So we have F, and then the C becomes E. نعملها بcolor مختلف. E, and then 9 here, colon colon 4 7, and then F colon F E, and then I will continue the rest of the address C3E0. Okay, so this is the full address, which is 128 bits. ماشي كده يا شباب؟ So we have 4 hex states, okay, to represent 64 interface ID, and another 4 hex states to represent the prefix. Okay, so this is the AUI 64 method. Again, we'll repeat that again for this. What is the Ethernet? What if the Ethernet address is this, and the prefix in that case is this. طبعا this prefix, by the way, if you observe this prefix اللي هو FE80, this is in the range of link local, right? So the router assigns a link local address to the nodes on the LAN, which is يعني typically what happens, because each node gets assigned a link local by default. Okay, but also the router may send a prefix in the range of global unicast, okay, which will allow the nodes to assign to itself a fully routable global unicast IP version 6 address, which again is composed of the prefix and the physical address of the node. Again, so we'll do the same. So we'll take this MAC address, we'll divide it into 2 parts, okay? So the part on the left-hand side, the 24 bits, are F99, and then colon, and then 48, okay? And the 24 bits on the right-hand side, which are 85, colon, C3E0, okay? And then in the middle, we'll put a fixed 4 hexadecimal digits, which is F colon F E. Okay, and then we will look at the 7th bit of this digit. The F is all ones, and by converting the 3rd bit into 0, it becomes D. So the address becomes as follows. So it will be F D instead of the F, and then 99 colon 48, and then FF colon FE, and then 85 colon C3E0. And then we'll add to this prefix, so it will be like this. So 2001. So this is the full address in that case. Okay. Any questions about this, Shabab? So this is the UI64 address, which is used as part of the Slack method. Are you following, ya Shabab? Any questions? Okay. طيب. to the assigned prefix in the range of link local and the assigned prefix for the range of global unicast, which we said that they get assigned to nodes by default. In addition to that, IP version 6 uses multicast address as a general way to represent the non-unicast communication, which means IP version 6 does not have broadcast at all. ها شباب? Never ever use the word broadcast when it comes to IP version 6. Okay, so we can use broadcast in the case of IP version 4, but not in the case of IP version 6 by any chance. In replacement of broadcast, IP version 6 defines multicast, okay, configurations to node by default. By default, okay? So the nodes will never use broadcast to send to all nodes. We call it all node multicast. But what is the implication of this? What is the implication of this? مش احنا we said that in broadcast, if the interface ID, if it's all Fs, we used to call it in IP version 4 broadcast. In IP version 6, we don't call it broadcast. If you have the interface ID all Fs, that might be a unicast address. Okay, that can be used as a unicast address. So if I tell you what are the number of interface addresses or host addresses for the case of IP version 6, using 64 bits. What is the number of interface addresses if I have 64 bits changing in the interface ID part? How many addresses do I have that I can assign for interface addresses? So in that case, to the power, تفضل. -1, برافو عليك. Not بقى -2. So we say this is 2 to the power 64 minus 1. Never ever put -2. Why? Because we said in the case of IP version 4, we said if it's all Fs, it's broadcast. If it's all 0, it's network address, right? If it's anything in between, it's host. In IP version 6, that's not the case. If it's all zeros, it's a prefix address, which corresponds to the network address. If it's all ones, okay, if it's anything otherwise, it's a global unicast address, including all Fs. Okay, so that's why we put -1, not -2 in that case. So remember this, very, very important. Okay, so IP version 6 defines 2 types of multicast addresses, okay, by default to nodes and routers. Okay, anyone knows what these are? For people who have watched the video. Any if no one answers, I'll select one by random method. أحمد طرشون عارف؟ Ahmed. The question is, what are the 2 types of multicast addresses that get assigned to nodes by default in IP address version 6? جاسم اتفضل. جاسم. Multitask. Okay. All router, أيوة. All nodes, multicast and all router multi. ماشي يعني that's not exactly, but I will consider it correct يا جاس. Okay. There is another third type. If we consider Jasim's answer is correct, there is another third type. حد تاني interested ياخد البونص؟ هاني, you know? Yes, the two types that Jasim mentioned are part of what we call assigned multicast addresses. So these include A, all nodes multicast, okay, and B, all routers multicast, okay. So this is what Jasim said. There is another major type here that was not mentioned by Jason. Do you know what this is? Huh? Solicited node multicast. Yes, هاني. Okay. تمام يا هاني. Okay. So what are these three types or two categories of multicast IP addresses? Assigned multicast addresses, they get assigned by default to nodes. By default. Okay. So when again the nodes start, there is a router here. There is a router here, okay, which again, as we said, it sends route advertisement to all nodes, including prefix, gateway, and so on, using the Slack method. Contained in this is actually also all nodes, all these nodes, by default, they will make themselves part of a group, multicast group, because we said multicast is to send to a group of nodes, right? Okay. So if all the nodes make themselves part of the multicast group, this is technically equivalent to broadcast, right? But as we said, in IP version 6, there is no broadcast. So all the nodes, they will make themselves part of a multicast group automatically. This multicast group will have, unlike IP version 4, which uses all Fs in the host ID part. No, in IP version 6, there is a fixed IP version 6 address to be used for all node multicast, which in that case is in fact FF02, sorry, 02, FF02 colon 1. This is the full 128-bit address. Huh? This is the full address. And this address is an address for multicast group that contains by default all nodes, which is technically broadcast, right? But here in multicast, we do not use the concept that all Fs in the interface ID is considered broadcast. We don't have this. So all nodes, they will make themselves part of a multicast group by default, which will have this address. So this address will contain all the nodes in the LAN by default. ماشي كده؟ طيب, in addition to this router is of course part of a core network which has many other routers, right? So these routers, they will exchange with each other some routing nodes, like as part of the dynamic routing protocols. Remember, we have OSPF version 6, we have REP version 6, we have this and that. So also these nodes, they need to, again, also exchange some messages, okay? So in that case, we call the message that gets sent to all the routers Okay, we call it all routers multicast. So again, we don't have broadcast. So routers can send to all, one router can send to all the routers around it using what we call all router multicast. And again, this has a fixed address, which in that case, FF02 colon 2. Okay, so when the routers start, they will make themselves automatically part of a multicast group with this address. Okay, so when a node starts, it will make itself automatically part of a multicast group using the address of ff02 colon 1. ماشي كده يا شباب؟ طيب, in addition to this بقى, we have what we call solicited node multicast. Solicited بقى node multicast is a little bit tricky. We don't have to get to the details. It's used for a technique called neighbor discovery. Okay, we don't have to know the details about this. What we need to know is how do we calculate this solicited node multicast. That's what we need to know here. So the way that we calculate this solicited node multicast is as follows. So we get again from the router a prefix. In that case بقى, the prefix will be 104 bits prefix, and that prefix is solicited and arbitrarily assigned. Okay, and this is not to be memorized. It will be given to you in the exam. مثلا, I can give it to you. I will give to you a prefix which has a /104. So all the 104 bits are fixed. Okay, and then we have the 24 bits, of course. طبعا 128 minus 104 is 24. So these 24 bits, we will get them from the global unicast address. So the node will by default get a global unicast address, which is 128 bits in the range typically of 2000/3, right? So the node will get itself a global unicast address, regardless بقى from Slack, from DHCP, from whatever. And then the node will make itself part of a multicast group, okay, which has a specific prefix which has a length of 104 bits, and then it will take the last 24 bits of the global unicast address and then concatenate the two together. And this will be the solicited multicast group for this case. And in addition to, which will explain this, we have a host has an interface IP version 6 address in the range of in the range of global unicast, technically, right? And this is not a prefix address. This is an interface address. How did I know this? Because this address has a prefix of 64 bits, right? So if we look at the first 64 bits here, somewhere here, okay? So the prefix is okay. So if the interface ID is all zeros, then it's a prefix address or a network address, okay? If the interface ID is non-zero, including all Fs, okay, then it's an interface address. So clearly in that case, this is an interface IPv6 address. Okay, so this is a full address, 128 bits. Okay, 64 of them is for the prefix, and the other 64 are for the interface ID. Which means that, remember here, let me just remove this. So here, the last, now what we are concerned with is the last 24 bits. Okay, the last 24 bits, because these are key to be able to calculate the solicited node multicast. Okay. So in that case, the last 24 bits are as follows. So here it's 0, 1, and don't forget that there is 2 zeros omitted, right? And then here we have 0, 0. So this is the last 24 bits. This is how they look like. Okay, this is the 24 bits. Of course, 16 bits here. These are 16 bits, and then 8 bits. 16 plus 8 is 24, right? ماشي كده? And then we have this solicited multicast prefix that's assigned. This is a prefix. It's a prefix address. It's not an interface address. Why? Because if we look at the last 24 bits here, the last 24 bits, let's look at the last 24 bits here. This 0 is in fact 0, 0, 0, 0, right? And we omitted the leading zeros, right? And these two hexadecimal digits make this interface ID all zeros. If it's interface ID, if the interface ID is all zeros, this means that this is a prefix address. It's not an interface address. ماشي كده يا شباب؟ طيب, so all we need to do is just to get this part and put it in replacement of this part. That's all we need to do. So the address becomes, so the address here becomes F0 2 colon 1 colon F, and then we have to put this part, which is 0 0 colon 1 0, and this will be a full 128 address. Of course, I omitted the leading zeros here. ماشي كده? So all we need to do is just to get the rightmost 24 bits and then replace it in the interface ID part, which here is 24 bits. That's all we need to do. Just to replace this 24 bits with this 24 bits. That's it. Unlike EUI64, EUI64 has 2 steps. So we get the MAC address, we split it into 2 parts, and then we put in the middle FFFE, and then we get the 7th bit, we toggle it, things like that. Here, it's just simple. We just concatenate the 2 together. ماشي يا شباب. Any questions here? So this lecture is in fact a little bit, يعني, I would say, a little bit abnormal. So it's good that some of you find it clear, especially people who have watched the offline video. I hope they have clarified, or they have many of the concepts that they have watched in the video clearer now. And that's the whole point about watching the offline video before you come to the class, because we have discussed here some techniques in details which are not usual actually to many students. So so hopefully these techniques are clear now, and you will get some exercises in the near future to try to get more familiar with these techniques. So I will switch here